Okay, sorry, didn't see that it was recording. This is our last video for section 4.2. We ended last time talking about the constant difference theorem, and I just wanted to show you one example of that. I'm going to prove an inverse trig identity. The inverse trig identity is that arc sine of x plus arc cosine of x equals pi over 2. This is not an equation we're being asked to solve. We're not asked to find what x values make this true. This is always true whenever it's defined. It's an identity. So for all values of x between -1 and 1, because that's the domain of arc sine and arc cosine, this is going to be true. Now this example is similar to example 6 in your textbook. Okay. So how I'm going to do this is I'm going to notice that, oh, that's a constant. Okay. So I'm seeing that this thing is constant. So I'm going to just say, let's take the derivative of the left-hand side. If the derivative is 0, then the theorem 5 tells us that if the derivative is always 0, then we've got a constant function, at least on the open interval between -1 and 1. Okay. So if I take the derivative of arc sine of x plus arc cosine of x, well, when we did this, we learned that the derivative of arc sine was 1 over root 1 minus x squared, and the derivative of arc cosine was -1 over root 1 minus x squared. Okay. But that's just 0. Okay. That's going to be true everywhere this is defined. Okay. Now, at the endpoints, when when x is 1 and -1, at the endpoints, these derivatives are both undefined. However, I know that arc sine and arc cosine are continuous functions. So if this is true everywhere between -1 and 1, it's going to be true at those endpoints as well. Okay. All right, so what this tells me then is that thus I know arc sine of x plus arc cosine of x is constant. Okay. So that tells me that it's equal to some number. It doesn't tell me that it's equal to pi over 2. I'm just going to pick a number to check. Let's let x equal 0. If it's constant, whatever its value at 0 is, that's its value everywhere. So I can say arc sine of 0 would be 0. That's the angle between -pi over 2 and +pi over 2, whose sine is 0. Only one such angle. Arc cosine of 0 is pi over 2. That's the only angle between 0 and pi, because remember that's the range of arc cosine, the only angle whose cosine is 0 in that interval. And of course, if I add them, arc sine of 0 plus arc cosine of 0 is equal to pi over 2. So if that's its value at 0, because the derivative is 0, it's actually 0 everywhere. So kind of neat and an interesting way of proving an identity that we really didn't know how to prove without the calculus. I guess we probably could have made a geometric argument, but I think this one's a whole lot simpler. So kind of neat to see that. Okay, that's it for 4.2. Short section.